My name is Jamie Busick. I'm the CEO of Blue Mile. Today we wanted to go over our cloud computing platform and some of the history of Blue Mile. We started in 2003. We are a carrier's carrier. That means that our customers are most of the tier ones, a lot of the tier twos, and a good portion of the cell phone operators and cable companies in the United States and all over the world. So we have interconnect points throughout the entire United States to facilitate our interconnect between our vendors and our clients. So to start with, back in 2003, we started building out our network. Our network consists of 4 cities today, primarily. We have Columbus, Ohio. We have Atlanta, Georgia. We have LA, California. And then we have New York City. Inside of New York City, we actually have 2 POPs. One is 60 Hudson, and then we have another POP at 111 8th. The reason we have all these locations is these are the major carrier hotels in the United States where 90 to 100% of all of the major carriers, 95% of all the other carriers show up in these locations so we can facilitate. This is 56 Marietta, and this is 1 Wilshire. This is where Asia comes in. 60 Hudson and 111 8th, this is where Europe comes in. Atlanta is some South America. And in the next year, we're planning on adding in Dallas. And we're adding in Miami to give us better connectivity to those southern markets. So we built out this network in a way that we had the most flexibility. So today, our network supports both SONET and MPLS. So now that we have all of this network, and we have a data center sitting in Columbus, Ohio, we've deployed SONET soft switches. We have co-location. We have transport that we can sell between the markets. And we have internet. All as products. So about 6 months ago, 7 months ago, we were doing about 1.5 billion transactions a day. And our internal back office systems that were supporting all of these various products started to overload. And we decided that we needed to start upgrading our own systems for our own benefit. And what we started to do is we found best-of-breed products, putting them together to create a private cloud for our own internal consumption so that we could put our billing, our back office, all of our customer-facing applications, and we could scale it out so we could do 3 billion, 4 billion, 5 billion transactions a day. So when we're doing about 5 billion transactions a day, we had to scale this thing out. And so what we ended up doing is building a private cloud. So today, our private cloud sits here. And that private cloud has now become a public cloud that we can sell to other customers, other carriers, you name it. So our cloud's comprised of a few different pieces. Starting at the very core of it, we have very fast storage. So we are one of the few cloud providers that actually puts in a true SAN. This is a EMC CX960. It's the very largest Clarion SAN the EMC sells. We didn't really buy it for the size of the unit, but more for the speed and the amount of cache we could get into it. So if you look at the top, you have redundant 64 gig cache, allowing our customers, our own internal systems, to hit the cache before it actually hits the spinning disks. Less moving parts, faster access. This unit connects to a high-speed pair of fabrics, SAN fabrics. Via, at minimum, 16 paths. Then we decided on the Cisco UCS blades for our shared and our virtual private server platforms. Every chassis holds 8 servers. We do 8 chassis in a pod. So these servers are slaved to very fast, lossless interconnect switches and are also slaved into the SAN fabric. So the interconnect switches are slaved up to here, giving us 16 paths per pod. So a pod is equal to 8 chassis or 64 blades, or 8 clusters. These interconnect switches come down to the actual blades themselves via multiple 10 gig connections. So each chassis is receiving 4 10 gig connections of Ethernet, or fiber channel over Ethernet. So tons of bandwidth, very much over-engineered. But the benefit is if you have a customer running on these different blades inside the system, they won't ever have to leave the interconnect switch before they hit the rest of the network. So the communication between all of their systems and building private networks within our cloud are very, very, very fast. We also have, at the core of our data center network, we have Nexus 7K that are also Cisco. This gives us a ton of flexibility, crazy amount of features, including TrustSec. TrustSec is 128-bit encryption. We can encrypt from the switch to any of these NICs on the box, all in hardware. So all of our customers can remain PCI compliant, HIPAA compliant, whatever compliances they might need regarding security are all accomplished right in hardware, line rate. We also have VRFs, which are virtual route forwarding instances. Which allows us to privatize the IP space. And then, of course, we have mini VLANs, which virtualize layer 2. So across all the parts, the actual switches, the SAN fabric, the SAN, and the blades, we're able to virtualize. Now on the blades themselves, we run the very highest degree of VMware, which is VMware's vSphere 4.0 Enterprise Plus. What this allows us to do is a few different features. We have DRS, which allows us to schedule and manage all the resources and the allocations to our customers that we give, where we can actually guarantee the amount of memory that each customer gets, and if the policy is being threatened, can move that customer seamlessly with a product called vMotion to another unit inside the cluster, so as to not ever have an issue where they don't have the memory or the CPU or whatever resource that we're guaranteeing inside of our system. What this, we also have is, by default, we do high availability. What this allows us to do is a guest operating system running on any blade inside the cloud. If we lose the underlying blade, the guest crashes, the SAN disappears, whatever the issue is, he's going to reboot onto another blade, open in the system, where we always hold back enough reserve that that can happen. This is always included for free. We don't charge extra for high availability. We also have the ability to do what's called fault tolerance, where we're mirroring in real time between two systems inside the cluster the image. There's a phantom guest and a live guest, and if the phantom dies for whatever reason, the live dies, the phantom will pick up automatically without ever missing a hiccup.